The data type enum exists in most programming languages, and it is there primarily to help make your code more readable. Here's an example of code that doesn't use an enum, but probably should. I have a function dayResponse that delivers a different message depending on the day of the week. Notice that the function returns strings. It doesn't actually print anything. So when we access it, we'd probably wrap it inside a print function. We'll say print dayResponse, and then if I want the response for Monday, I would put 0 in as the argument. Notice that I receive day as a parameter, and then I have a series of if statements that decide what to return based on the integer day of the week. Let's try this. So I got the response, ACK Mondays. That makes sense. The problem with this is that it requires the developer to remember that 0 stands for Monday. And that's not to mention some other programmer who comes back to maintain this code. You can imagine that this would be a nightmare if this were a more complicated program. So what we would like to do is have some symbolic reference for each day of the week. And for that we use the enum class. Enum is not built in, so we need to import the package. And we're going to say from enum in lowercase, import enum in uppercase. Now the enum class is available to us. Remember that we talked about inheritance as one of the 4 principles of object-oriented design. The enum class is a base class. It has certain functionality built in. We're going to inherit from the enum class to create our custom class. And we'll do that like this. Class day of week. Remember that class names are always in upper camel case. And then we inherit from enum. So we put that inside the parentheses. Now we're going to create constants that represent each day of the week. Our constants should be in all caps. And I assigned values to each day of the week. These values are somewhat arbitrary. Traditionally they are integers, and traditionally they start with 1. In fact, we're not restricted to numbers at all. We could use strings on the right-hand side. And that might be convenient, but for now we'll stick with numbers. Now we can go in and change all of these abstract numbers here that really didn't mean anything into days of the week. If you think back carefully to classes, these are all class variables. So to access them, we would write the name of the class followed by the class variable. Now instead of an integer data type, this will be a day of week data type. And now, when we want to access the dayResponse function, instead of passing an obscure number like 0, we'll pass the day of week dot Monday. We run the program, and it works exactly the same. If we change it to Tuesday, then of course we'll get our message for Tuesdays. We can access the names of the items in our enum by using the name attribute. So I can print day of week dot Monday dot name. And it prints out Monday. That might not be very useful. It took us a lot of words to just get that Monday out. But another fact about enums is that they are iterable. So we might like to iterate over the days of the week. And in that case, it may be useful to have the name. In this case, we iterate through each day and show the message for that day. Now we do get this all uppercase result because of the convention that each item in an enum class should be uppercase. But I mentioned that we can use strings as the value for each item. So we might make the strings equal to a nice printable day of the week. And instead of printing day.name, we'll print day.value, and it looks a little friendlier. We've just scratched the surface of enums. There's a lot more functionality, and I encourage you to look at the official Python docs to find out what more you can do. But I hope you can see their value in readability and maintainability of code.